Okay, in today's demo, we're going to take a look at using Liquibase to enable us to build quality into our database change pipelines while keeping unwanted changes out. And we're going to look at some techniques for building trust into what we're doing, building quality in, if you will, through the use of a single source of truth, the Liquibase changelog, and shifting quality left, shifting the checks left to before the pipeline using the Liquibase quality checks. We'll also look at how you build an inspection regime into the process so that you have the verification that goes with that, the verify that goes with the trust, if you will, using the Liquibase diff and snapshot capabilities to analyze the databases, make sure they haven't drifted off of their expected configuration while we're moving changes through the pipeline. For our environment today, we're using a real basic setup. We've got three environments, a dev, a QA, production. It's all Microsoft SQL Server databases, and we're just using Git and Jenkins to show what's going on. Kind of keeping it simple so it's real obvious to everybody. It's something you can learn from and take and maybe apply in your own environments. And the Liquibase version that we're using today is Liquibase Pro version 4.6.2. Okay, so with that, we are going to jump in and I'll walk you through some examples. Okay, for our example, we're going to look at this Liquibase changelog. And the Liquibase changelog serves as the single source of truth, a human readable record of not just the changes going into the database, but also metadata that controls the behavior of those changes when they get there. So it fulfills the role of code in an infrastructure as code mindset as we drive changes through our pipeline to our databases. Now, like any infrastructure as code type mindset, we set this up, we define what we expect to happen and commit and push this into our source repository. Again, in this environment, it's Git, so I'm just going to go over here and commit and push the changes in, and then we're going to go and run them through our pipeline. Now, the pipeline, before we start running it, bears some discussion and description. Its workflow is to first, of course, retrieve the changes from the source repository and bring them to where we can work them. Then it's going to run them through the Liquibase quality checks, where I can go in and see if these changes meet my criteria. We'll look at them in a few minutes, but the Liquibase quality checks are a customizable set of checks that ensure only the changes you want to let through automatically are allowed to proceed automatically. We'll do a drift detection. Is the database in the state I left it before I deploy my new changes? There's no point putting new changes into a database that's already got unexpected changes on it since the last deployment. Probably should resolve that so that we can actually trust the environment. Then we're going to do some testing to make sure that the deploy and rollback processes actually work. And then we'll finalize the deployment and take a new snapshot. If everything works to that point, we know these are good changes. Then we'll finish up by refreshing the snapshot. So at the next job, we have a known starting point to compare from and repeat as necessary. So let's go ahead and run it. We've put our changes in the source repo in Git. So we're going to go ahead and kick off a job and run it against the dev environment. And so the job's going to run. It's going to go retrieve that change log and run it through our quality checks. See what we've defined here. And it looks like we found a problem. So let's go in and inspect what's going on there. So if we go back and go up to the top of the report that it produced, so I'm running Liquibase Pro, so I get to run a whole bunch of quality checks against my change logs. But as it turns out, the one that I'm failing on is one of my new change sets has a grant in it. And the rules as they've been defined in the quality checks in this environment say that grants are not permissible. So, okay, I can review the rest of the report, make sure that it's checking all the change sets I expect. It will go in and check everything it finds in the change log at the change set level. And it'll even give me a little report of what checks were run. Okay, so it looks like we got a problem in there, and I should go find that grant because the safeties here won't let me put that into the pipeline. That could cause problems. So let me scroll down. Here we go. Yep. Sure enough, there's a grant here. And as it, I actually don't need this grant. If it was something I needed or was important, I could run it as an exception through the process. But for here and for now, I don't need it. So I'm just going to delete it so I can get the rest of these changes into the pipeline. Repeat my commit and push. So if you're familiar with continuous integration, this should look familiar. This is that shift left doctrine where we're inspecting the changes as close to creation as possible, giving fast feedback to the developer, giving the person who created the change, the developer or whoever, the opportunity to correct that change and resubmit it for the next build. Basically unbreaking the build I just broke. That's kind of the mindset here. So I'm going to go ahead and do that. I've recommitted what should be a good set of changes. I'm going to go and I'm going to kick off the run. See if we get through the process this time. So we're back. It's going to rerun the quality checks, reinspect my change log in case I made any other changes. Looks good this time. The environment checked out against drift, so the dev environment looked the same way as when I last left it. So I can trust that these changes should go in clean, I should trust the outcome of the in and out test here, deploying and making sure the rollback processes work properly, and finalizing the deployment. Looks good. So now it's just going to do some cleanup, capture the snapshots so that the environments are ready for the next run, and I should be good to go. Great. That's pretty cool. So I feel good about that. I trust the environment was where it should be, so my changes went in clean. So everything's good. I feel comfortable then. I should be able to promote these to the QA environment. Okay, so just go up here, run the job, select QA, and off we go. So we'll see the same pattern repeat. It's going to retrieve the changelog that we now, we've run through, know it's good, serves as the source of truth for the deployment to the next environment, to the QA environment. Unfortunately, the drift check on the QA environment didn't work out. There's something wrong. There's something there where it's listing that it's got an unexpected change or a set of unexpected objects in the database. So I can go in and inspect that. I've got a handy link to the file. And it turns out there is a table out here called ZZ Unexpected that I probably need to look into. Okay, so go out to the ever popular SSMS, look in there, and indeed there's the unexpected table. Well, that's no good. Now I can go hunt down where this came from, figure out who put this there. It could be benign. One of my colleagues was running a test and just left it behind or whatever. Or of course, there could be a bigger problem. Obviously, if I can't find a colleague who put this here and we don't know where it came from, we probably have some security concerns. Actually, unexpected tables are an indicator of database malware or even ransomware. So keeping an eyeball out does in fact matter. In this case, I know it's benign, so I can just delete it and move on, come back to my pipeline and rerun the job. Right? I still know that the changelog is good. I trust that. I trust that it went into dev. I've got the data and evidence to prove that that's a safe thing. I believe I have brought the QA environment correct, and indeed I have. That was the only problem in the diffs. Terrific. So we'll go ahead and deploy the changes out to the QA environment, walk through the rest of that, and we should be good. Assuming we pass the rest of our validation here. And as usual, once we're done with that validation, we're going to take a snapshot of the environment, so that we have that reference point stored for what the database looked like immediately after its deployment. We can come back and inspect that at will. So we've seen the jobs run a couple of times. We've walked through the pipeline and worked against a couple of different environments. We've seen how we can take a source of truth in the form of Liquibase changelog and run it through a series of checks to make sure that the changes themselves are trustworthy, and looked at how we can use Liquibase to inspect databases to make sure they're trustworthy. I've got the quality and security that I expect going into each of these environments. So the next logical question is, well, how did I do that? What did it really take to put this together? And simply put, there are three things that you need to understand in order to build a pipeline like this. The first is, of course, Liquibase changelogs. I touched on those earlier. I'm not going to really revisit them at this point. There's plenty of reference material and free education at liquibase.com. We actually have a thing called Liquibase University where you can learn everything you ever wanted to know about changelogs and then some. The other thing that you need to understand is the Liquibase command line. What commands did I use and exploit to build this out and what's possible with them? And then the last thing is how do those commands stack up in an automation tool so that you can get an idea what that pattern might look like, give you some ideas for how you might at least take some of the ideas and replicate this kind of mindset about trust and safety into your own pipelines. So let's jump down to the command line and start there. What are the commands that I'm using, and how might they help you? So the first thing I'm going to do is I'm going to make sure that I've got a connection set up here in my workspace. And I do. Okay, so I'm connected into the dev environment, which is what I wanted. So good. So we'll start off with the quality checks. And the Liquibase quality checks feature is a built-in thing. It comes with a number of quality checks out of the box. And these serve as a starter point. You can use these and customize these to match your own requirements. And out of the box, they serve to give you patterns for common things like security concerns. You don't want people building grants or revokes in, kind of like the example we saw. Maybe you're concerned about dropping objects, things that might be harmful to data or cause data loss. Maybe you're concerned with structural standards in the database. Do things match my naming pattern and what have you? So I can institute, all tables must have some kind of a naming pattern around them, or any various object type that I might be interested in, I can look at, and so on. And so there's a whole set of these comes out of the box. You can customize these. And I'll just take a quick look here at the what's possible in terms of setting these up and configuring these. And the idea is that you take the out-of-box ones, make a copy of them, customize them to match your requirements. You can turn them on and off and even set the severity level associated with them so that some may be just informational, others may be things that you want to stop the process in one way or another, and ensure that the changes are just halted cold at that point and never get into the pipeline. And again, that's what we did in the example I showed you earlier, where we didn't want the grant command to go into our pipeline. And of course, very easy to run these. I can just by executing these, I can run them, and it's going to do exactly what we saw in the automation job. I've got the no problems found list of all of the change sets that were inspected and all of the checks that were run on all of those change sets. So pretty simple process. The checks are defined in a file that you can store in version control, so you can ensure that the same checks are used everywhere and repeatably. And you can kind of tweak these depending on the standards and concerns in your environment. The second thing that I used was the snapshot and diff capabilities in Liquibase. And what I did there was simply to take a snapshot of the database immediately following a deploy. So I deployed some new changes to the database. I want to know exactly what it looked like immediately following that deployment. Capture that information in a file that I can store and use at a later point in time to verify that the database still looks like how I left it. If snapshots only come from valid deployments, the database should always look like the latest snapshot. Pretty simple guardrail to have in your pipeline. So in order to do that, all I really had to do was use the handy dandy snapshot command to a file. So I'm just going to create this example.json file with the snapshot. It's going to go out there and run. So I should now have an example.json file here in my directory, and I do. Very nice. And of course, this is a text file, easy to save off and store into a repository as necessary. And with that, I can use my database connection to compare it. So I've got a defined connection to the dev database, and I'm going to compare it to the snapshot file. And I'm going to get my response to that compare in JSON format. So it's going to go out, run that compare, and tell me what it found or what it didn't find. So this is exactly the kind of report I would want to see. No differences were found. The only information in this file is, in fact, what the target was and what file I used to run the diff in the first place. I don't see any unexpected objects. I don't see any missing objects, and none of the objects changed since that snapshot. Those are the 3 checks we were running in the pipeline to make sure that the database was starting in a state that we expected before we did the next deployment. With that understanding, we're going to go jump in, take a look at the pipeline definition, and see how we put the knowledge of the changelog and the batch of changes together with these commands to get that safe, trustworthy and inspectable pipeline experience that we saw in the example. The last thing we're going to do is look at the automation job that drives all of this. How do we take the command lines that we were just talking about and put them together into a coherent pipeline, kind of like the example we just saw? So we'll go over here. This is the pipeline file. It's a Jenkins file. I like using them because they're good for laying things out for people. They've got a good structure so people can generally visualize the flow and get an idea of what's required to make something like this work. We're going to start off at the beginning and retrieve the changes from source code. We've got to get the changelog out of Git and all the other supporting information files down into the Automation Tools workspace so we can run it through the pipeline, make sure that we're getting what we expect. And then we're going to run through the various stages. Now, as we get in and start interacting with the tool and the databases, you'll notice that we are using the credentials plugin. And what that is an encrypted store for credentials elsewhere in Jenkins, and just using the Liquibase Pro facility to bring those into environment variables. It's a more secure way of processing that information. It's kept externally. I'm not asking people to know it or hard coding things anywhere, putting them on the command line. It just gets read natively by the tool and ultimately is a more secure way of doing it. We can't be thinking about quality and security in our pipeline if we're not doing things in a more secure way as part of it, right? So let's get on to the commands that we're running here. So we're going to run a couple of commands first, just to quality check the changelog. First is the Liquibase validate command, essentially make sure that the changelog is parsable, which is a good thing to do just in general. You don't want to do too much more if you can't parse it properly or if there's an error in it. And then, of course, run the Liquibase quality checks command, just like we were just looking at in the command line. This is that it's running the quality checks I've defined for this pipeline and making sure that the changelog is compliant. If it's not, as we saw, this job will stop. Once we've got that, and we say, okay, the changelog is good, we feel like these changes have quality built in. The next thing is to make sure that we can, in fact, trust the database, do some verification. And this is where the diff comes in. So we're going to run the diff command against the latest snapshot. And if in the output of that diff command we find missing, changed, or unexpected objects, again, the job will stop. Assuming we get through all of that and we know that the changes are trustworthy and the database is in the state we expect, there's no unexpected modifications from a coworker or a malefactor, a bad guy, if you will, we'll go ahead and start through the deployment process. Now, I've put a pattern in here that I particularly like, which is that of making sure that we do a deployment of the changes first and put some documentation around that by tagging the deployment, documenting what changes are being deployed into the database, and even generating a dry run of the SQL that's going to be used to do all of the changes. And after we've got the bureaucracy out of the way, we actually go ahead and deploy the changes. But I don't like stopping there, right? Everybody is concerned with the safety of the changes and, have we got the ability to roll them back if we need to. So I like building in a test of the rollback, at least in the lower environments, the sub-prod environments, in this example, to make sure that we're not just documenting the rollback process, but we're actually testing it. We've got lower environments to test things in. Why aren't we testing our rollback process just as much as the changes themselves? Seems like a good idea to me. So I was like recommending this to people as something to think about as they're building their pipelines. So I'm going to do the same thing. I'm going to do a dry run of the rollback and then actually test the rollback. And it's only if I have proven that I can put the changes in and take them back out with the rollback that I go in and finalize things. I'll put a final update in, right? So once I've put them in, take them out, redeploy them for reals this time. And after that deployment, that's when I take the snapshot, right? I now have done everything I can to ensure that the changes are good, the database is good, and the deployment was successful. Now let's take a snapshot of that database for the next comparison. I've got to reset the latest snapshot, which I do down here. Keep a record of the file as it is. So a version of the file with the job number associated with it. So I've got that for record keeping and audit trails down the way. And of course, updating latest, so I've got a known compare point for the automation job. Once I've done all of that, did a little cleanup, I go ahead and add this, commit it and push it to the Git repository so that I have them saved for perpetuity. And that's where the job ends. I've completed that automated workflow that we saw the example of. So relatively straightforward. It's just a sequence of commands leveraging the power of the Liquibase tool to deliver the quality and safety and security into my pipeline as I run each and every job. So hopefully that's helpful. Hopefully that's something useful, maybe gave you some ideas for how you can build or improve your database change delivery pipeline and support your applications and further your DevOps journey. Thank you very much.